In section 9.8, which is the last section of chapter 9, we're going to factor polynomials completely. And what do I mean by that? Well, let's jump right into some examples so that you see. So here's one scenario where we have a binomial that shows up twice. We have 2x minus 1 and 2x minus 1. So we're going to factor that out. And what we're going to say is that if we have 5x times that binomial plus 3 times that binomial, we can write this as 5x plus 3 in parentheses times that binomial, 2x minus 1. So now notice that instead of having one product added to a second product, we now just have one product. This is going to help us out when we go to solve equations. Okay, scenario 2 is when we can group together terms that will factor out into hopefully a common binomial. So for example, what I would suggest you look at here are the coefficients and look at the ratio of the coefficients. Here for example we have a ratio of 1 to 4. And then with 3x plus 12 we have a ratio of 3 to 12, but that's equal to a ratio of 1 to 4, which matches. So let's see what happens when we pair these two terms up, then pair these two terms up, and factor out what we can. So we have x cubed plus 4x squared. We're going to look at those two terms. And then 3x plus 12. Look at those two terms. From the first two terms, we can factor out x squared. And this will give us x plus 4. From the second two terms, we can factor out 3, which will give us x plus 4. And notice that we end up with x plus 4 twice, which means we can rewrite this as x squared plus 3 times x plus 4. And now notice instead of simply having 4 terms added all together, we end up with a product. Again, this is going to help us for solving equations. A third example is where we can factor a term out from an expression, and in some cases this will help us again solve equations more easily. So here notice that 3 goes into all of the coefficients here. So we can factor that out as 3x squared minus x minus 10. And then we need to check and see if this can be factored further. So if we look and we make an x here, we have a product of negative 10, a sum of negative 1. So we're looking for two numbers that multiply to 10 that have a difference of 1, because these are going to have opposite signs. 1 times 10, those have a difference of 9. We could take 2 times 5, those have a difference of 3. And those are the only ways that we can get 10. And what that means is we're not going to be able to factor this any further, and that's our answer right there. 3 times x squared minus x minus 10. Oops, sorry, I skipped something here. Skip problem 1. So example 1, solve the equation here. So again, notice that we have x plus 4 shows up twice. So I'm going to take this expression, 2x plus 1, and then minus x minus 10 in parentheses. Put this all together, so I'm going to enclose it in brackets, times that common binomial, x plus 4. This is equal to 0. Now within the brackets we can do some simplifying because we have like terms. We have 2x minus x is equal to x. 1 minus negative 10 is equal to 11. So x plus 11 times x plus 4 is equal to 0. Notice we have a product equal to 0. So that means one of those two expressions has to be 0. So x plus 11 equals 0, or x plus 4 equals 0. Subtract 11 to get negative 11, or subtract 4 to get x equals negative 4. Okay, now number 2. We have 7n cubed minus 5n squared minus 42n equals negative 30. I want to get everything over to one side, so I'm going to add 30 to each side. Now we have 7n cubed minus 5n squared minus 42n plus 30 is equal to 0. Whoops, equal to 0. So now look at the ratio of coefficients. Here we have 7 to 5. Here, if we divide each of these by 6, we get a ratio of 7 to 5. So let's factor out what we can from the first two terms. And here we can factor out n squared. So that will give us 7n minus 5. And from the second pair of terms, we can factor out a 6. And I want the first term to match the sign of this one. So I'm going to factor out a negative 6. 42n divided by negative 6 is positive 7n. And then 30 divided by negative 6 is negative 5. So we end up with 7n minus 5 twice. That equals 0. So we get n squared minus 6 all times 7n minus 5 is equal to 0. So now we have one simple product equal to 0. That means that either n squared minus 6 equals 0 or 7n minus 5 equals 0. Here we would add 6 to each side and then take the square root. Make sure that you take both the positive and negative square root of 6 because both will work here. Or add 5 to each side, 7n equals 5, and then divide by 7. So we end up with 5/7. Okay, so here we actually have three solutions: the positive square root of 6, the negative square root of 6, and 5/7. Okay, number 3. Now for a few problems we're going to factor. So no equation to solve, but we're going to factor. Notice here that if you look at the first two terms, we have 28 and 6. We can divide each of those by 2 to get a ratio of 14 to 3. But here, 24 and 7, we have no common factor, and so we're stuck with a ratio of 24 to 7. So those don't match up very nicely. Let's see if something else will work better for us. What if we were to match up the 28 and the 24? We can divide each of those by 4 and get a ratio of 7 to 6. And if we look at these two terms, we already have a ratio of 6 to 7. So that looks good. So we can say this is equal to 28xy plus 24x. And then I'm going to rearrange the order of these two terms because we want to match the ratio. 7 to 6 in the first case, so I want to switch these around to get that ratio of 7 to 6 rather than 6 to 7. So negative 7y minus 6. So we're going to factor out what we can from the first two terms, which will be 4x. And then we end up with 7y plus 6. And then from the second two terms, again, we want the sign to match up here, so I'm going to factor out a negative 1. So minus 7y plus 6. So this is equal to 4x minus 1 all times 7y plus 6. All right, number 4, 28mn plus 21n minus 49m minus 12n squared. Again, looking at the ratio of coefficients, 28 to 21. Both of those can be divided by 7 rather, and we get 4 to 3. But here, these have no common factor. So we're stuck with 49 to 12. That doesn't work very nicely. So let's try something else. What if we match up the 28 and the 49? There, both of those can be divided by 7, and we get a ratio of 4 to 7. And then with 21n and negative 12n squared, we have a ratio. We can divide both of those by 3. We get a ratio of 7 to 4. So those match up. So I'm going to rewrite this as 28mn minus 49m. And then again, this is 4 to 7, so I want to rearrange these terms to get a 4 to 7. So minus 12n squared plus 21n. So from the first two, see what we can factor. We're going to have a 7 and an m. So that leaves us with 4n minus 7. And then we want the sign to match, so we're going to factor out a negative 3 n, and that will leave us with 4n minus 7. So lo and behold, we end up with 4n minus 7 twice. So this is equal to 7m minus 3n all times 4n minus 7. All right, number 5, 40k squared plus 130k plus 75. Notice that we can divide each of those terms by 5. So I'm going to factor out a 5. We get 8k squared plus 26k plus 15. And now we need to see if we can factor that trinomial. So here we have a times c will give us 120. The value of b is 26. So we're looking for two numbers that multiply to 120 and add to 26. So we could take 1 times 120, 2 times 60, 3 times 40, 4 times 30. These add up to 34, so we're starting to get close. 5 times 24, so those add up to 29. We're getting closer. 6 times 20, those add up to 120. So we have 6 and 20. So now we can form our box. And we know that we have 8k squared. And we have plus 15. And now we know that we have a 6k and a 20k. So factor out the greatest common factor. Each row we have, here we would have 2k, and here we would have 5. Here we have 4k, and here we have 3. So this is equal to 5 times 4k plus 3 times 2k plus 5. And now we have factored completely. And notice again that we have a product. If this were set equal to 0, we would have a product equal to 0. So one of those terms would have to be 0, and it couldn't be 5. So that would leave us with 2 equations to solve that would be pretty straightforward. Okay, number 6. So here we have an equation. Solve 3x to the 4th minus 39x cubed equals negative 66x squared. I'm going to add 66x squared to each side so that we get everything on one side of the equation. So now we have 3x to the 4th minus 39x cubed plus 66x squared equals 0. And notice we can factor out a 3 because it will go into all of those coefficients, and we can factor out x squared. So 3x squared times x squared minus 13x plus 22 is equal to 0. Now see if we can factor that trinomial. So if we set up our x, we have a product of 22, the sum of negative 13. So how can we get 22? We could take 1 times 22, but those add up to 23. 2 times 11, those add up to 13. So we have a negative 2 times negative 11 will give us 22. Negative 2 plus negative 11 give us negative 13. So now we can rewrite this as 3x squared times x minus 2 times x minus 11 is equal to 0. So one of those 3 terms has to be 0. So 3x squared equals 0, or x minus 2 equals 0, or x minus 11 equals 0. Here we can divide by 3 to get x squared equals 0, and then take the square root, x equals 0, or add 2 to get x equals 2, or add 11 to get x equals 11. So you might find this section a little challenging, but nevertheless, I hope you enjoy. Good luck.